Hey everyone, welcome back to another episode of the engineering side of data. My name is Bob Haffner. I'll be your host today. My guest is Caleb Welchans, and we're going to be talking about GIS, which is Geographic Information Systems. I say the acronym so many times that sometimes I forget what the abbreviation behind it is, or what they stand for, as it were. So, Caleb, thanks for coming on, and please introduce yourself.
Yeah, thanks for having me on, Bob. Really appreciate it. Love the show.
Thank you.
So I've been blessed with a diverse background in the tech world. Started off in supply chain analytics and then moved deeper into the technical world from there. So I cut my technical teeth in logistics engineering and then moved into technical management over in an analytics and design department. So from there, expanded into business intelligence, enterprise data management, GIS, and some decision science. My last move actually involves me taking a responsibility of the enterprise GIS team, Geographic Information Systems, as you mentioned, at a leading environmental services organization. So I've been fortunate enough to have leaders trust in me along the way and give me new opportunities, but just somehow, GIS always finds its way back into my life. So happy to be back at it with the GIS teams and slugging away.
Nice. Yeah, it sounds like that GIS has been a part of your career in some fashion, and definitely now more than ever. And GIS is like my second favorite topic to discuss. Data engineering obviously is first, but I love GIS, and I think data engineers, they should have some level of familiarity with GIS and what it can do and its use cases. So hopefully everybody, all the data engineers out there will find this an interesting conversation. I'm sure they will. All right, let's get into the questions here. So I guess the first one's pretty obvious. What is GIS?
Yeah, so the acronym stands for Geographic Information Systems. But really, the way I like to describe it is applying location to data and then using various ways to display it. So it typically comes from actual data points or elements in the form of, points and rows.
Yeah.
Raster and vector images that you see in maps and other applications that require that kind of visualization.
Nice. Which industries leverage GIS typically?
Yeah, so obviously I'm in environmental services, so we as an industry leverage GIS quite a bit. From that, there's obvious reasons and areas that we apply it to, such as real estate, that mean those industries leverage it as well. So real estate uses GIS. Supply chain, which I've been involved in the past, leverages GIS. Urban planning, insurance, utilities, surveying, anything that involves some sort of location-based need for that business to function. The largest player in the space is obviously local governments. So understanding where you live, where all of their assets are, and how they can best leverage their land management applications as they move forward. My personal favorite industries that use GIS are things I use every day. So mapping applications, Google Maps, Apple Maps to get around. And yeah, like I said before, I think everybody checks Zillow to see what the new price of their house or location is pretty frequently. So.
Oh, absolutely. Yeah. Got to check out the house value. Yeah. You mentioned government. I think that was probably very surprising to me when I first got into GIS, when I started attending some of the conferences way back when, is how much local governments leverage GIS. It was quite impressive. It was they have such a presence, and I think a lot of the popular, and we'll get into the tool set, the software behind it, but I think a lot of the software kind of started off serving that role and starting off in that public sector and then moving into the private ones, some of the ones that you mentioned. So yeah, it's crazy popular in the local governments. So what are some common use cases with GIS?
Yeah, so I found GIS to be, just an additional layer on top of data that you may already be using as an organization or in a personal use case. So you can use it in obviously identifying location where you are, but also routing different objects to and from each other with different origin destination pairs. And it just explodes from there. You get things like mapping visualizations, which goes into the field of more specialized cartography, or you can get into just more geospatial analytics from drawing geofences, putting buffers around locations to see what's within a certain distance radius, miles or kilometers, or whatever you may use. You can do things like market analysis, determining what area is hot or cold. The most common use case for that I think everybody's seen more recently than not is the infection rate of COVID-19. So people were loving using maps to show hotspots across the globe and how it was traveling in different patterns across different countries and things like that.
Nice.
Also, there's, like you said, government use cases. As I attended conferences when I first began, I remember I was sitting in a row and turned to talk to the people that were sitting next to me, and they were both from government agencies. I was like, oh, I can't believe this. And sure enough, more than half the people I met at the conference had some sort of either use case or job with the United States government, which is where we are. So, they use it quite a bit. One of my favorite conversations I've had with people is just using it for land management over huge national forests and parks. You get areas that, don't have cellular or wireless service that you can connect to the internet with. And so they go out and collect information and use the different tool sets to upload it to better maintain the land or animal populations that are involved in those locations as well.
Wow. You mentioned a term called geofencing. Could you elaborate a little bit more on that?
Yeah. So geofencing is when you take a location and draw essentially a border around it. A lot of people use buffers of a certain degree or just simply draw an outline of an actual location that you're a part of. So a common use case that you see is from warehousing. So you have the actual physical location of the warehouse, but there's the quote unquote yard around the warehouse where all of the trucks or different transportation modes wait to load and receive their goods before they depart the actual warehouse facility. And so they'll draw a geofence around the entire property of the warehouse, including the parking lot. And when you get that update of your package is being delivered, it means it's crossing a threshold that was set in place that was a geofence around that location that gave you that alert.
Now that makes sense. Yeah. So GIS is kind of its own thing sometimes, or it could be integrated into other departments. What do you typically see the GIS world living in a typical data architecture, I guess? Like, where does it live within the organization?
Yeah. In my current location, we have a team on both what we call the business side and the IT side. That seems to be a usual implementation that I see across a lot of organizations. But there's other organizations like government agencies that centralize it into one GIS team, or utilities companies that centralize it into one team. And so they are the analysts, infrastructure support, all the people that go about implementing different GIS solutions for the organizations and stand them up and support them as they progress as a company. I personally have liked those centralized deployments because it allows you to share a lot more if you have that attitude going about GIS data and services that you can provide as an organization. So you can have a place, if they're willing to and capable of it, sharing that location element on top of everything else with the organization to leverage as a strategic asset.
Yeah, sounds pretty pervasive. Absolutely, in a lot of organizations. So we've got a nice, I guess, a high-level description of GIS. If we kind of drill down into the weeds a little bit more, what would you say are the main components of GIS or pillars? And maybe that's a better word for it.
Yeah, main components of GIS, I would say, are actually the data elements. So you get geometry types that you see a lot. Most commonly, the most unique point or data element in GIS is a physical point or location. We get things like lines and polygons as well, which are those geofences that we talked through earlier. Also, some fundamental components of GIS are some sort of visualization aspect to it, which generally finds its way through a dedicated UI and application, but it can be spread across a lot of different ways. You've got different tool sets along that entire path that enable you to enable and make the data more actionable along that path. So whether it's strictly at the data level, whether it's at some sort of analytical level, or some sort of visualization level, you've got tools and aspects to help you leverage it along the entire life cycle.
Gotcha. So going back to that geofencing example you mentioned, that's kind of that's typically when they say, hey, let's put a geofence around this location. That's a representation. It's a polygon, essentially, right?
Yes.
And then if you have, maybe that's your house, right? And then if you have like an Amazon delivery, that the delivery driver could be hooked up. They have their GPS. They're giving out these points, these XYs. And once they're inside that geofence, that's when we get the notification that, hey, your package has arrived. So all those geometry types and those spatial operations kind of work hand in hand. That's pretty fascinating. All right. Yeah. What is the GIS tool set, or I guess software packages? Yeah. Let's talk about that. Who's making the stuff to make GIS happen?
Yeah. So if you're not familiar with GIS, which I wasn't when I first stepped into this world, there is a major player in the industry known as Esri. They have a full suite of tools and applications that you can use to both enable and leverage GIS as a strategic component of your organization. So they do everything from helping you engineer your data to a certain degree, manage your data, move it, as well as continue down the pipeline of manipulating it, analyzing it, and visualizing it through their suite of tools. From there, you can also create applications that you can publish to websites or domains that you may need to, or just host them yourself for leverage on your own machine. They are the biggest player and also the most useful. So if you're looking at GIS, chances are you're going to be looking at Esri. That's what they use in the majority of schools across the United States, as well as the government taking part in a lot of Esri tools as well. So chances are, if you are getting into the GIS space, that's a great place to look. On top of that, there's lots of other free tools that are out there that may not be as capable, but can definitely get the job done. Some of those are QGIS, which also has a lot of those transformation tools that you may need. So one of the examples I like to use is with different polygons. You may have data elements that overlap in an actual physical location or in a visual aspect. You can perform different functions on it, like clipping or merging, to then create one giant polygon or to cut out different aspects. So it's like cool tools to get to create new things and ways to look at the data. You've also got tools like Google Earth, which I've played around with quite a bit. I remember when they first let you download it to your desktop, everybody zooms in to where they live first, I think. You can zoom all the way in, right? And that's a great place to get to experiment. And they also have their own data formats that you can use to visualize on top of Google Earth and look at your data that way. Going on from there, you've got direct data applications that you can use with it too. So you've got databases that can enable spatial elements within them, or you can use specific tools like PostGIS, which we've implemented in our past and been able to leverage quite successfully for hosting spatially enabled data. You can host GIS data in data warehouses like Redshift and SQL Server and things like that. So it's pretty common within the industry as soon as you enable it. You've also got different software libraries that you can use, or development libraries like Python, Shapely, or GeoPandas, or you can use different development tools like Leaflet or D3 as different visualization aspects for your GIS data. But one of the fun things I've been seeing recently as a trend within the GIS space is people recognizing the power of GIS. There's plenty of examples in my career where people all of a sudden would have a lot of questions about data sets or locations, or where should we put this, or where is that? And if you create a map and present it to those people asking those questions, a light bulb goes off. And it's a great progression of adding GIS to active conversations and then getting it to be a conversation starter. And so from there, I've seen, as my career's progressed, GIS fit its way into different BI and analytics tools. So you can use GIS in Power BI now using Bing, or there's even some Esri plugins that you can use there. Also, Tableau has their own implementation, and Click does as well. So when you're visualizing your data, no matter if you have spatially enabled it or not, you can always add that data element and perspective in to your application to show the whole picture of your data when it comes to spatial aspects. So if you're, let's say you're a national company in the United States and you have divisions amongst the actual different states, you're not just showing a chart or a table that says, Delaware's outperforming Texas this quarter. What's going on? Well, maybe you can actually create a heat map within Power BI or Tableau that you can click through and dive more into the analytics and the data discovery aspect of it, which I think, all data engineers and data analysts and data scientists really, they want people to engage with their tools and their creations of data. And I think it's a great way to introduce people to those concepts and also keep them in them as well.
Yeah. No kidding. Yeah, I think that it's hard to argue that maps are not the single most powerful visualization that's out there. You can have a good bar chart or, line graph or dashboards or any other visualization, but if you have a map, that is, it's incomparable what you can accomplish with that. So, and I also, you mentioned, I like to highlight databases when I talk about GIS, and like you said, the Postgres extension, I think PostGIS or PostGIS, however you want to say it, and SQL Server, and even a lot of the popular data warehouses, like you mentioned, with Redshift and Snowflake. It's you're seeing them supporting, geometry, those data types, like you mentioned before, the points, the lines, the polygons, and then all the spatial operations that you can dream up, right? You can do a spatial join. Which points are in this zip code? Writing, query language, SQL, using these things. You can calculate the distance between two geometry objects. I mean, it's pretty impressive and actually quite extensive. What they have for the in the industry for software. So yeah, good stuff. How does moving on to kind of the career aspect? I imagine a lot of this stuff has piqued a lot of interest so far in the conversation with folks that are listening and watching. How does somebody start into a career with GIS?
Yeah. Well, I think the first thing you can do is just start poking around. Like I said, Esri's the big player, but they're also one of the biggest contributors to the space as well. GIS is one of those things that once you start to get into it, it kind of ignites a passion. You feel like you can change the world with GIS, which who knows, maybe you can. But GIS has a lot of great content out there that's free and available to consume that goes through not only their tools, but just what is GIS? What does this spatial join mean? How do I perform this kind of function? And they can walk you through a lot of those things. One of the biggest, things that I've experienced as I've progressed in this journey is just different GIS YouTube channels are great, but also just diving in and messing around with it. And I truly believe that once you start to think about data with a spatial aspect, it starts to make more sense as you start to explore it. So I would highly encourage someone to just go out there and make a map in whatever application that you've been using to consume or transform data. Just throw it on there, see what it does. See if you can grab the lat longs and play around with it. See if you can spatially join your data by state or county or however you identify location. And just put it on there and start playing with it. You'll see a lot of cool things come from there. One of my other favorite ways to explore it is just in like Jupyter notebooks. And as you're going through exploring your data in that aspect, you can again throw a map out there and just see what it looks like. By doing those kinds of things, you're inherently going to learn. But like I said, there's a lot of great resources out there, both from Esri and from other content as well. If you just type in what is GIS, like I did last night, you get a ton of hits. And there's some great websites out there that'll walk you through, like, what is GIS? What does all this mean? How can I start to implement it and apply it to myself throughout my career? I think it's an easy move to expand into if you're looking to just kind of expand your career and having different tool sets under your belt. Being able to apply spatial analytics to different data sets is a great tool to have. And like I said, if you're able to visualize it from there, you can bring awareness to a lot of people and also bring awareness of yourself to your organization or whoever you're sharing that with.
I love that advice. I like that. Just get started, right? Explore, get some tools, get QGIS, that desktop mapper. I've never personally used it, but I hear great things about it. It's free, open source. You can do a lot of great things with that. Maybe it's Power BI and maybe you're a Tableau person. Try that out. If you like Python, chances are if you're listening to this podcast, you do have some Python experience. Like Caleb mentioned, there's a ton of, there's Shapely, there's GeoPanels, and probably my favorite is Folium. I got to put a plug out there for Folium. And of course, Postgres with the PostGIS extension, PostGIS. So yeah, absolutely. Yeah, I love that advice, Caleb. All right. So I love asking these crystal ball like questions, right, about the future of the topic, right? See what the guest thinks about, what's going to happen 5 years down the road, 10 years down the road, whatever it is. So what do you see? How is GIS going to change? Who's going to be using it? All those things. What should we be looking for on the horizon?
Yeah, I think one of the things we should be looking for as we continue in this space is just the conversation around sustainability. I think with discussions like climate change and all that coming about, is companies are becoming more aware of how they can be more sustainable. And if you have a large physical footprint, guess what? GIS is a great way to start looking at that and understanding what your actual footprint is on the environment in the world. So as the different major players in the GIS space start to focus on sustainability being an actionable item within their tool sets, you're going to naturally see it expand into different organizations. I think it's a good, easy place to start exploring it as an organization. You get all kinds of factors from greenhouse gas emissions and real estate and those kinds of things of what does this look like for us as an organization or as a people. So I think that's going to be a big catalyst for this industry and GIS as a whole. being able to play into that. Also with just global economies in general, starting to track their information. People, throughout the coronavirus pandemic realized that there were some real significant supply chain implications that, may or may not have been caused by the pandemic, but were definitely exposed through that. If one piece breaks, the rest of it might. And, GIS is a great way to add on to your supply chain analytics or understanding and be able to see if there's bottlenecks by location or anything like that. So yeah, I think with the push from those two big topics, supply chain and sustainability, we're going to see GIS expand here in the future. There's going to be a bigger need for it at organizations as they try to, if they're public, sell to their shareholders that they're being more eco-friendly and conscious. And there's just going to be more of a need for it as these BI tools start to incorporate it into their workflows. And like I said, the visualization aspect of it lights up a lot of people's eyes and imagination. And how can we leverage GIS better in our organizations, whether it's an actual department person or if you're just a BI developer, incorporating it into your applications and dashboards that you're sharing with people.
Nice. So more GIS for social good and just more GIS for the sake of GIS. I like it a lot.
Right.
Yeah, that's right. Yeah, I imagine we'll find a lot more uses for it. Maybe, just being more and more pervasive, more integrated into the applications as the need and the technology develops. So, yeah. Hey, great. I love this conversation. I really appreciate you coming on and sharing some of your thoughts about GIS. So thanks for coming on the show.
Yeah, thanks for having me, Bob.
Right on. And for folks at home and listening in the car or wherever you're at, go to the YouTube channel, subscribe, like the video, subscribe on your favorite podcast app. And thanks for tuning in, and we'll see you at the next episode. Thank you.